6:30. Welcome in for another safety focus of the week. Today is January the 5th. This week's code of conduct is to work to VOSHA, OSHA, FRA, and ECI safety standards. My favorite code item. So just some quick safety news. How we're doing is we had 6 days without from our last recordable injury. We did have a crushing of the foot injury due to an employee lost control of a swivel, landed on their foot. Unfortunately, they were wearing, at the time, it was kind of more of a rubber muck boot type without steel toes, and it crushed the toe, had a pretty bad fracture of the toe. So good reminder. We're going to talk about it later in the meeting. Take advantage of the safety toe reimbursement program that we have. Again, we really like to see safety toe out there, but also personal lifting. If it's a heavy object, let's try to use team lifting. I mean, this was about a 70-pound object, which is still pretty heavy, but again, doesn't always help to ask for assistance when you have awkward lifts that you have to make. So it's been 2 days from our last first aid. Oh, sorry. Go ahead, Ben.
So Matt, that related to our code of the week. The last part of that was to follow ECI safety standards, and some of our theory and thoughts on our safety program way back from when we wrote our first manual was to have the responsibility to protect ourselves from the hazards of our work. And that was the way it was written. And protecting ourselves, always think about the ECI standard is that system that begins with engineering out the situation all the way down to the final and last line of defense, which is the PPE. So that code item being your favorite, I'm thinking that some of the essence of our safety program involves that hierarchy of controls, and having engineers, construction, having engineer in the name, try to engineer out the situations that could avoid this type of injury. So yep. The leadership that you all have out there to recognize someone else in harm, the whole everything leading up to somebody having something dropped on their toe, there's a lot of opportunity, and that last line of defense could have helped in this case when all else fails of those steel-toed shoes. And that did go up from $125 to $150 for reimbursement recently. So anyway, wanted to add that.
Yep.
Thanks.
Thanks, Ben. Yep. Thanks, Ben. Well said. And then first aid, we had just kind of fatigue shoulder reported coming in on Monday. So tracking that one, but first aid. So good, proper lifting, ergonomic type of injuries that we've seen over the last 2 weeks. So we'll try to get Amy in here for another kind of a wellness series, a little bit on mechanical lifts, keeping everything in our power zone. This week, want to highlight working over water. It is a OSHA standard. We have a lot of it coming up between Montpelier, Bridge 145, the project we're doing at Fort Ethan Allen, or the firing range. We have a lot of exposure there. We have been nabbed in the past with a compliance officer of us not wearing personal flotation devices, working on a slope in Pittsfield back in 2018 or 2017, something like that. So I just wanted to kind of highlight the standard, how we want to tackle that using our best practices and our ECI safety standards. So the biggest thing with working over water, what we're trying to avoid is that drowning hazard. That's one thing that we're definitely worried about as an employee drowning. So kind of utilizing the hierarchy of controls that we kind of mentioned about earlier. What we want to try to do is isolate people from the hazard. So setting up a guardrail system we can, or using a personal fall arrest system. If we eliminate the fall, the drowning can't occur. So that's kind of how we want to work from the top down. We want to try to work that way if we can. If we can't, then really what we need then is to wear flotation devices. So if an employee lands in the water, they're going to be risen to the top. So we do have, for the winter work, we do have flotation, winter flotation jackets, especially for the crew up in Alberg. They're utilizing those. If more crews want to utilize those, please contact Health and Safety. We'll purchase more. So far, we're hearing good positive feedback from these flotation devices. So let us know, and we're staying on top of it between all of our site visits. But that's kind of our standards of how we want to tackle the drowning hazard. And then the last thing, this is a very quick standard to talk about, but the last thing is to always have a rescue plan. So the standard says we need to have ring buyouts with at least 90 feet of line shall be readily available, and then one life skiff shall be immediately available. So that's if someone does enter water, how are we safely going to get them out of the water? So that's kind of the standard in a nutshell, and that's how we want to operate working over water or near water on our operations. Pretty cut and dry, pretty straightforward, but it's a good topic for us because we're doing a lot of this work right now.
Hey, Matt, I recall maybe not all the exact details on that OSHA citation, but the guy wasn't really working. He would just happen to be at the top of slope, not even
Correct.
working on a slope, not on the slope itself, I don't believe, but one of those things where OSHA feels compelled to do something, even though it wasn't technically strictly within their regulations. And then they didn't even fine us because they obviously didn't feel that it was a real violation.
Yeah, but we
still,
did have
need to be aware of that.
Yeah, we spent a lot of energy fighting that one, so if we can avoid those confrontations with them, I think it's best practice if we can.
Yeah, so sometimes my point too is don't even give them the opportunity to appear to be in a violation. Just make sure we're on the proper side with the proper PPE and everything, and avoid coming near those red lines, especially if OSHA's on site.
Exactly. Well, that's all I have. Any other questions? Contact Health and Safety. We're here to guide and to help and to assist. So please utilize us.
Sounds good. Thank you, Matt. I'll take over the screen. Okay, can you see my screen?
We got it.
Okay. So for announcements, this is kind of short notice because I hadn't noticed that I was given this last week, so it didn't get in last week. But the Morgan Stanley Financial Advisors will be here today on Friday the 5th of 2024. Wow. So half-hour meetings are available from 8 to 11:30 for employees to discuss their 401k, and you can contact Melanie to get an appointment. So there's a few openings there, which sometimes isn't the case. So if you're thinking you should kind of start out the new year with some thinking and focus on your 401k, this is a good chance to get on board and get that done today. And I left this in here. This is the 2024 compensation and benefits overview. This is from last week, but there was a copy sent to everybody by email last Thursday. So if you need it, check with the administrative office, Gina especially, but anybody should be able to help you there. A couple of changes. We talked about the safety tow boot purchases with an increase in that. And then the winter floating holiday reminder, because we're in that time where you can use your floating holiday. And pretty exciting news. Oops, it's moving too fast here for me. Pretty exciting news. I guess I didn't really put a heading on this, but for our employee 2023 employee giving, it got closed out this year at $27,018.44 by employee donations, and ECI brought it up to $30,000. So checks are going to be written to 4 charities for $7,500 each. We got the Classic Mike Lawyer Foundation, the Make-A-Wish Vermont National Guard Charitable Foundation, and the UVM Cancer Foundation, patient support side. And our sweatshirt sales added an additional $11,417.50. An additional $1,040 was added to the UVM Cancer Foundation, and then an additional $10,377 to the Mike Lawyer Classic Michael Lawyer Foundation. And our recipient for the sweatshirt sales for 2024 has been chosen, and it's going to go to Make-A-Wish. So anything you buy from sweatshirts and t-shirts and things like that goes to the Make-A-Wish. So ECI purchases all that swag, and anyone who buys it would all the money goes to charity. We get pretty much a good deal for the employees, and all that goes to charity. And then next week, we have scheduled anyway, Lindsay Long from the UVM Medical Center Cancer Center will join us on next Friday safety meeting to say here quick thank you to everybody. So I left the announcement on the employee giving here, but that's pretty cool stuff. Pretty proud of everybody in the company and love to see it.
Yeah, thank you,
I have the
everybody.
link. Yeah. I have the link to the ECI Primary Care Wellness Program. Great time to be thinking about that, being the beginning of the year. You know, we need to, we're a year older, right? And we need to be thinking about our wellness, and every year things get a little more complicated as you age, right? So for this week, we're going to talk about, for the project, the Royalton BF 014729, which is a bridge project on the railroad bridge overpass. And we have Ken Howard and Ben McKinney are going to present. Want to take over the screen, Ken, or you want me to scroll?
I'll have you scroll. I can't seem to get it to open on my browser. So
Okay, I'll scroll a little bit so you can start. Okay.
So ECI is contracted with VTrans to replace the NECR bridge at milepost 3501 that passes over Route 14 in Royalton. Currently, the bridge creates a low and narrow underpass, and many who drive in the area are familiar with it. We highlighted it early in the year where we talked about the drilled shaft construction that serves as the foundations for the new bridge. Since then, we've performed much of the roadway and drainage work and completed 3 shutdowns where we installed 762,000 pounds of precast in a temporary bridge. The first shutdown ran from a Friday morning to Sunday at noon, where we installed 2 retaining walls at 83,000 pounds each, and an abutment cap, which was 112,000 pounds, at abutment 1, which is the closest one to the old bridge. And then we panelized the track. Since it's all CWR, we had to cut it. And then when we were all done, de-stress and re-weld it at the end of the season. Here the guys are taking out a track panel for the first shutdown. The next picture
Okay.
What's that? Yep, you're good.
Okay. All right. Good.
The next picture here, we're just excavating behind the existing abutment and around the drilled shafts. In 2020, you'll see how the new abutment looks in these pictures, but in 2024, the rest of the wing walls will end up out in Route 14 where it exists now. So we couldn't do it all this year until the extended closure next year.
This is a incredibly tight S-turn on the existing alignment, right, for the highway, and that's part of the problem there.
Yeah. So the heavy pieces require getting CCS's crane, 275-ton crane, as close as possible. The sheets on the right here in this picture are there to get the crane close, but leave just enough room for the wing wall return. So that wing wall that's in the air there, the footing wraps around the drilled shaft, and there's a return similar to the one on the left that wraps around the drilled shaft. So it's pretty tight. And then that outrigger pad is supported by 3 H-piles that are hidden to keep the lateral load off the sheets in the deep section of the cut right there, which I think is about 10 feet. Of course, in these shutdowns, we're under some pretty intense deadlines, so we're working rain or shine. Yeah.
Sometimes it
pretty-
breaks.
Yep. Sometimes it rains in the middle of the night.
overall, I think we're lucky. I don't know why I didn't, I thought I put text here
Yeah.
and see what happened. It didn't save for some reason. That's kind of the default text that Constant Contact gives me. So you'll have to ad lib this part.
So this is, we were starting to grout where the wing wall hits the wing wall footing. So those two big pieces, you know, came separately. So we tripped the wing wall up, and this is where we're grouting. And of course it was raining then, so we were trying to keep everything dry. That's what.
I'll just chime in real quick, Ken. Some of you guys might be familiar with this system. You know, where you have a retaining wall on a footing. And so of course you have to develop tension in that back face of bar, number 8 bars in this case, several dozen of them. And you know, like a number 8 bar, you know, standard lap splice length might be like 4 feet or 5 feet. In this case, they've just got a little female sleeve, again, dozens of them, in the base of the wall that a very small dowel in the footing goes up into. And it's a proprietary system with a special grout that you pump in through the ports you see. That actually develops full tension of the 8 bar. So it's a pretty neat system for work like this. But, you know, the grouting is critical because that's where all the strength is.
Very cool.
We were actually waiting. It kind of was like, we're like, you know, we were waiting for the grout to get strength so we can continue. So it took a little longer than expected. Of course, these are some heavy picks and require some of our heaviest rigging. Here's some picture of Brad in front of some 55-ton shackles with pretty heavy shackles.
Yeah. And what's interesting is how light the you know, the twin path or whatever types of straps these are, synthetic straps.
Yeah, synthetic.
They're high capacity, or like you could carry it around on your shoulders really easily. It's just it's bulky and not heavy.
It's a lot nicer than wire rope, that's for sure.
Yeah, that's for sure. Okay, let me get. Oh, see, I had another one that kind of. When I looked through this and checked my draft, it was all changed and a lot of stuff didn't get saved. Constant Contact was acting weird last night, that's for sure. So go ahead.
So after backfilling the retaining walls, the cap was set onto the drilled shafts and grouted. The cap will sit, or the cap currently sits below the track structure until next year when we excavate it out during the 134-hour railroad shutdown, which also falls in the 20-day roadway shutdown. Here we are setting the cap on top of the drilled shafts. There were some anchor bolts that stuck up. I think they were like 3.5 feet into the cap.
Back up and went maybe ahead of you there. There we go.
No, you're good.
Right.
You can barely see the anchor bolts in that picture, but.
Yep. Okay.
And the next one's Gunner. Gunner's doing some layout on the cap as we're setting it, or he's checking as we're setting it, because you know, each piece has to go into pretty tight tolerance position, because next year the bridge, not only did we have to, you know, land this cap on top of 2 drilled shafts that were built independently, we have to put the new bridge, you know, has to obviously sit on both abutments that are 125 feet away from each other.
And that rigging again, those straps, those lifting straps that go into the structure, they were intense.
So second shutdown ran from Thursday morning, so from a Thursday morning to a Sunday at noon. So we gained an extra day. There was a couple more pieces. The 2 retaining walls, which were 79,000 and 86,000 pounds apiece. A couple wing walls, one small one, and then another. Kind of like all the other 3 are going to be is 91,000 pound wing wall that sets onto that footing that we showed grouting a couple minutes ago. And then the abutment 2 cap were all set during the second shutdown. And then in this picture, you can kind of see some of it, but for some reason, the designers decided to step the footing 5 times across the abutment. It was kind of unnecessary and added some extra time and complications during grouting and the shutdown, but all worked out. We set, so in this next picture, you can see a lot of the precast is already set, but we set one retaining wall between the shafts on the left side and then the wing wall footing. Then we tripped the wing wall, braced it, grouted everything in place, moved the crane around and set the other side. Kind of one of the silver linings is that, to all those steps was that the excavation was shallower on the east side and required less support of excavation and support of the crane on the other side. We were able to engineer some relatively simple crane pads instead of doing sheets. We did just waste blocks, and you can see the crane sitting on some mats and waste blocks on the other side. You still had to get pretty close. They were still pretty heavy pieces. So here we are tripping wing wall 4. It's the first one we did, but they call it wing wall 4. So too tall to ship upright and too heavy to be cast monolithically. So I tripped it. It was pretty gnarly. We thought we kind of figured it out, but we never tripped kind of a diagonal piece like this before. So when we first started standing it up, the spreader beam itself was at a wicked angle. And then the rolling blocks started to do their job a little better as we picked it up and everything evened out. We had a rated turnbuckle there. It was pretty heavy duty to get it the right length.
Is that the one we had in house, or did we get a different one for that?
I think we bought that one for the job.
There's in the project photo or the archive photo, we're lifting with a turnbuckle.
Yep.
Not quite as heavy as this. So let's see.
So on this next picture, you can see the wing wall sticking out of the embankment. That's what people will see in the future. And of course, eventually they'll see the face of the abutment. Everything to the right will be excavated eventually. That's where the new bridge is going to go. And the new road will end up going through there. And the tracks still have to come up 3 feet from this picture.
To the left.
So after all that, in the fall, we installed a new temporary ballast deck bridge. Well, not part of the contract. This extra step allowed us to raise the track to final grade before the extended closure. ECI constructed the new temporary bridge in-house using the SLR bridge 109 as a starting point. So that was a open deck bridge that we removed from Milan, New Hampshire in 2017. And then we added a top and bottom cover plates. The top one was full width along with those knee braces and sides that hold the ballast stone in the deck. The idea there is that we have this ballast deck bridge where we can just surface through and raise the track the 3 feet that we need without constantly raising the bridge up.
The initial elevation is shown with the tracks and system, and then the 3 foot raise shows just barely fits in there in your knee bracing. Pretty cool.
It's pretty heavy. Here it is.
Going when it's full of ballast. Okay, here we are.
Here they are during the little closure that we did, putting the new bridge in, or new temporary bridge in.
I forget what it weighed when we pulled it out, and the base bridge with the 6 stringers, but I think we welded 30,000 additional pounds of steel on it. From memory, I don't remember what the base bridge weighed. But I want to say the whole assembly ended up being 50 or 60,000 pounds without ballast.
Then what's that? Another 50 ton with ballast, I think.
Yeah.
Got to be, especially when you fill that up.
There it is. We had raised it a little bit from the original in this picture. I forget it. Maybe we raised it 10 inches. Still has to come up quite a bit. Then to finish the year out, we built the new bridge. It's 127 foot long and weighs somewhere around 400,000 pounds. High Steel brought the girders in 4 loads and ECI spliced them on site. This picture here is just one of, it's not really a half, it's like 2/3 of one of the girders.
So they had a little extension trailer that with 4-axle extension trailer underneath
I
the
think-
girder, obviously.
I think that's I forget what they call it, but it's not an extension trailer. It's, you know, that
Little
back
trailer,
end
little trolley.
yeah.
It's steerable.
Trolley.
Yeah, steerable by remote.
So how do they
It
get
was
it
pretty
out of
good.
there? Were
What's
you
that?
able to swing the girder, or you just lifted it up?
We just lift it up and then boom down to get it to the other side of the trailer, or we lashed it
Yep.
to some H piles that we drove in the ground.
They were able to roll that trolley out or something.
Yep.
Cool.
Yeah, they after they set the girder. Well, yeah, then they just moved it out of the way. Yep.
Yeah.
Here's Jason on top of the beam, Brad on bottom. They're splicing that together. Each one had 608 volts, and it was basically a day for each splice.
I hit the button too much. There we go. Sorry about that.
Very good. It was kind of shiny when it came, but it's rusted now.
A lot of bolts.
So we were responsible for steel erection plan, engineered steel erection plan for this interim construction condition. This included girder, lateral supports, crane picks, lateral torsional buckling checks, temporary foundations, and then a careful sequencing to avoid inducing unintended stresses in the structure. Those girders are 9 foot 3 deep, and they're pretty robust. They've got 3-inch thick flanges on them, and so do all the floor beams. Actually, they're pretty beefy. Here they are. You know, all the girders are spliced. They're getting the lateral bracing in.
Pretty cool.
The next picture, it's all the bridge. The steel is complete, and the guys are putting the timber on for the deck.
Very nice. So there's
Yeah.
some super elevation here.
Yeah, for sure.
Quite a bit. Yeah. Just shows on the next picture here.
Yep, there it is with the completed deck. Looks pretty sharp. Of course, rail will go on that in the end. So also just wanted to note some of the other work we did. We did a bunch of drainage and roadway work this summer. This next picture is the 670-foot run of 30-inch storm pipe that we did, showing some of the deeper sections below Meadow Lane, which was a little residence that passed through the job. We were able to use those extension shields that go on the side of the box instead of double stacking. It made it a lot easier than dealing with more spreaders. And then here's a picture of the completed. Next one is a picture of the completed Vesper Road. There's 370-foot road work for another side road that we reconstructed on a slightly new alignment with a full box cut and lots of ledge removal. Pretty significant cut on the end of the road too. It's like 10 foot lower now because of the new alignment.
Very good project. Very cool. Very well organized. Lots of cool stuff there, Ken.
It was
Great
a fun one.
presentation. A lot of work was done this summer over there in fall.
Nice.
Well, thank you very much, Ken, for presenting, and I apologize for the goof ups on the text there. It was constant contact, didn't kind of finalize it properly for me because I put all that in and spent a lot of time on that. So on the project archives of the week, I have the precast back wall installation for the Green Mountain Railroad Bridge number 130 in Cavendish back in May of 2010, and I have a picture of Jim Laughlin in our TCC 450 crane. Get down here. It advances. There we go. There's Jim up there. Guys are on the ground. Looks like a rainy shutdown day. And you can see there's a turnbuckle there on the front of that L-shaped piece. And the reason we did it that way is just to give it adjustability. We had to install it underneath an existing bridge, a through truss bridge, and this piece was probably one of the outer pieces of 3. So we had kind of careful adjustment to get it in there and have clearance from the rigging against the bridge. So that's what I got. Thank you very much, guys. And Matt, I'll turn it back over to you.
Yeah, awesome. If you're watching group setting, please just send over email, text, however, just so we can capture attendance of the meeting this morning. Let's have a safe day. Let's have a great day.